So in our last example, number 36, we looked at an equation that was already in slope-intercept form. In number 37, this is also in slope-intercept form, but in this particular problem, it's also a special case. Remember we talked about OI and VUX. So this is the equation OI, where we have a slope of 0, because 0 times anything is going to make this term disappear. So you can remember HOY tells me that the slope should have been 0. And the B value in this one is -7. So when we graph this line, it's going to make that horizontal line. And then to make the graph parallel, we'll keep the same slope. So it'll be another line with a slope of 0. And then to make a line perpendicular, we need a vertical line. So we'll use the VUX to remind us that the slope of that line will be the one that is undefined. Let's go ahead and take a look at that on a graph and see what it looks like. So we're going to change this to y equals -7. And so you can see this red line down here is the one that we were given. And if I wanted to have a line that is parallel to that, I can use that slider there. Notice that all of these stay horizontal. We're just changing the value that y equals, or changing the value of the y-intercept. So if I wanted to make a line that is parallel, I just need another line that's equal to a different number. I'm going to go ahead and set this one to y equals 3. And then our second one here is y equals 2. And notice that all of the blue lines, no matter where I move them, are going to be parallel to the red line. Until I get back to y equals 3. And then the blue line is on top of the red line because they're really the same equation, so they make the same line. And in order to change this, I need to change my y into an x to make that vertical line x equals. Okay, and again, we put a slider in there so we can move this line around. Any line that equals x is going to be perpendicular to the red line here.